Okay, this video I will teach you guys how to prove the geometric progression formula. Okay, so three formula here. First is the Tn formula, okay, and then we have the Sn formula and the S infinity formula. Okay, I remember last video I did for arithmetic progression, and for arithmetic progression there's no S infinity, right? Yeah, but for geometry there's S infinity. So I will show you how to prove the S infinity in this video. Okay, so first I will start with the Tn formula, right? So I'm just going to write down the first formula here. Tn equals AR power n minus 1. Okay, so this is the formula I will prove now. Okay, that I will try to derive this formula now. Okay, this Tn stands for when you are finding the nth term. Okay, this formula is to find the nth term, right? This formula is to find the sum of first n terms. Okay, Sn is for you to find the sum of first n terms, and this one is the sum to infinity. Okay, so how do we prove that how can we derive this formula, right? So first of all, we need to know T stands for term, right? So if I say T1, we are saying that it's the first term, right? So T1 is basically just A, okay, because it's the first term, right? T2 will be A times with R, okay, A times with R, and the R is the common ratio, okay, because when we write geometric progression, the first term is always A, okay, the next term will be A times R, okay, times with the ratio. If it's arithmetic progression, instead of times you will plus, right? Okay, but you plus with the difference, which is the D, right? But geometric is different. Geometric is in times. Okay. So then what about T3? T3 will be A times R. It means from here to here you times R. From here to here you times R. Can you see it? A times R, you get AR, and then A times R, you get A times R again. Right? Let's write one more. What about T4? So T4 will be what? It will be T3, which is A times R again, because you will times R here, right? And it just keeps going, right? Okay, we can write this a little bit different. R times R, we can erase and write it like this, R power 2. Because R power 2 is R times R, right? It's the same thing. Then what about R times R? This is basically R power 3. Okay, R power 3, right? So you can see a pattern here. Can you see the pattern here? This one is A, this one A times R. It means this one times R 1 time, this one times R 2 times, this one times R 3 times, right? So now we can generalize, right? So we can generalize. So when we generalize, we want, okay, sorry, I'll just write it here. Right? So when we generalize, then we can write the formula for Tn, right? Because we are trying to prove derive the formula for Tn, right? So this 1, 2, 3, 4, that's the n, right? That's the n, right? So your n keeps changing, right? From 1, 2, 3, 4, okay? But if you look at the formula, all these formula have A equal A, right? So when you generalize, there will be A here also, okay? And did you realize all these equation here, they got times R, right? This one times R power 3, times R power 2, times R. Okay, nothing here means times R power 1. Okay, you should know this. Then what about this? This one you can see there's nothing here, right? Okay, if there's nothing here means, okay, what do you think? What do you think this one is actually what? If this is R power 3, this one R power 2, this one R power 1, this must be what? 3, 2, 1, this must be R power 0. And it makes sense because R power 0 is 1. Okay, anything power 0 is 1. You can try with your calculator. Anything power 0 is 1. So if R power 0 is 1, it means it becomes A times 1, which is A. That is why the R power 0 is invisible. You cannot see the R power 0 because R power 0 is 1, and when you times 1, it makes no difference. That's why when you times 1, nothing happens. That's why usually when it's times R times any number power 0, we don't write it because power 0 is like you just times 1, and when you times 1, nothing happens, right? But since we are trying to generalize, So I will write down the r power 0 so you can see the pattern more clearly lah, right? So that's the reason I'm writing the r power 0 here. So now you can see the pattern here, right? So a times r power 0, a times r power 1, a times r power 2, a times r power 3. So here it will be a times r power what? So this one is 0, this one is 1, this one is 2, and 3. So you can see that when the n is 1, the power here is 0. When the n is 2, the power here is 1. When the n is 3, the power here is 2. When the n is 4, this is 3. It means the power here is always 1 less than the n. Do you agree? When this is 1, this is 0. You see, the power is always 1 less than the n, right? Same with here. The power here is 1 less than the n here. See, 1, 2 minus 1 is 1, right? 3 minus 1 is 2. 4 minus 1 is 3, right? So what you can write here is a times r power n minus 1. It means whatever number here, whatever number I put here, I have to minus 1 to get the power here. Okay? Because that's the pattern we notice from all these equations, right? So 1 becomes 0, 2 becomes 1, 3, 2, 4, 3. So if this is n, this must be n minus 1, right? And that's it. That's how you derive the formula, right? So Tn is ar power n minus 1, Tn is ar power n minus 1, right? The times, if you want to write, you don't have to write the times, it's fine, okay? Because when you don't write anything here, it already means times, right? So you can just leave it like this, right? So that's all. So I'll just write derive, right? So that's the first formula, done. Now I will move on to the second formula. I'll try to derive the next formula, which is the Sn formula. Can you see there's two different versions? One is okay, focus on the denominator, right? The denominator here is 1 minus r, and if this is 1 minus r, up here inside the bracket will be 1 minus r power n. But if down here is r minus 1, then up here inside the bracket will be r power n minus 1, right? This one flip, the atas also flip, okay? So there's two formulas, right? But I will only teach you how to prove this one, because this one and this formula, the way we derive is very similar. Yeah, the chart block is the same. Okay, I'll show you now. Okay, I'll show you now. So I will write down the Sn formula first. Sn. So I will show you how to derive this formula. So a bracket 1 minus r power n over 1 minus r. Okay, I'll explain to you how to derive this also later. But it's very similar to this, right? It's just you just change the working a little bit. Okay, so I will show you this one first. So remember, this formula is to calculate the sum of first n terms. It means you are not calculating the first term, second term, third term anymore. You are calculating the sum. Yeah, the sum of first n terms, right? So what I'm going to do now is I will calculate the sum, right? So instead of taking T1, T2, T3, T4, I will have to plus them together because it's the sum. So it will be T1 plus T2 plus T3, and then it keeps going, right? So plus T3 plus T4, it keeps going. Okay, you will keep going until which term? Okay, do you realize, because you are trying to find the Sn, it means this is the Sn, right? Sn, the sum of first n terms. And we don't know the value of n now, because we are trying to derive the formula for Sn. It means we don't know what is the last term. We don't know the n is, we don't know what is n, right? So I'm just going to write here Tn. It means my last term is Tn. Okay? So imagine if this is S7. Imagine if this is S7. It means what? It means sum of first 7 term. If this is S7, it will be sum of first 7 term. Then it means it will be T1 plus T2 plus T3 plus T4 plus T5 plus T6 plus T7. If it's S7, right? If it's S9, then here you will plus, the last term will be T9, right? But since I don't know the n now, so it will be Tn here. Okay, understand, right? It means this is my last term. Tn is my last term, right? So the number of terms here depends on the n here. Okay, that's what it means, right? And now what I'm going to do is I will use this formula to calculate the T1, T2, T3. It means now it becomes Sn equals T1. I already know it's A. Okay, T1 using this formula, right? T1. So you will just sub 1 inside here, so it becomes T T1 equals to A times R power n minus 1. But the n is 1, right? So 1 minus 1 becomes 0, right? But we don't have to write the R power 0 because R power 0, I already explained just now, it's 1. So it's just A times 1. So we don't have to write the 1 because A times 1 is the A, right? Plus with T2, T2 is this A times R power 1, okay? Because we use this formula, right? So I'll just write here AR. Because R power 1 means R, so A times R is AR, right? And then the next one is T3, right? So T3 will be this, A times R power 2, right? R power 2. So I'll just write AR power 2, alright? And it keeps going. Yeah, it keeps going. It keeps going until the last term, which is Tn, right? So what will be the Tn? Well, it will be this, Tn, which is AR power n minus 1. So I'm just going to write it there. This is our last term, AR power n minus 1, right? Now, what we can do here is I will take all these terms, multiply with R. It means I'll take this whole thing times R, right? It means everyone has to times R. So when I times R, this thing becomes R as n because I times with R, right? Later you will understand why I times with R, okay? So now you just listen first, right? So later you will know why I times R, okay? So now I times R, it means if here I times R, everyone here I have to times with R also, right? So what happens to the A here? The A will become AR. Do you agree? Because I times R, right? I multiplied with R. So this one times R becomes this, okay? And then what about AR? What happens when AR times R? It becomes AR power 2. Okay, AR power 2, right? And the next one, let's say AR power 2, I times with R. What happens here? It becomes AR power 3, right? And of course, there's a lot of terms in between here, alright? So I'm just gonna put dot, and then for the last one, I will also times with R. So what happens if this thing times with R? So it becomes AR power n. Yeah, it becomes AR power n. Let me show you. Let's say I'm taking this AR power n minus 1, I times with R. So what will happen is the A, nothing will happen to the A. The A just write it, right? Only the R and R can times together because they are same base. So it becomes A and then times with bracket. Okay, this one is R power n minus 1 times with R power 1. Okay, nothing here means power 1, right? And when you have two numbers that are same base, and then when you want to times them together, the power you need to plus. So it becomes A times R power, the power here you need to plus. So it becomes n minus 1 plus 1, like this. So now it becomes A times with R power n, and then negative 1 plus 1 is 0. That is why it's AR power n. That's why here I write AR power n. Okay, so now you understand where this thing come, how this thing come from, where this thing come from, right? So now I will just erase this. Okay, I think I'll erase this also, right? So this is how it looks like now. Okay, I want to do something extra here. I want to add another term before the last term, right? So let's squeeze in another term here. So can you tell me what will be the term before the Tn? It will be T. Okay, imagine. T1, T2, T3. I already said, right? The number of terms here depends on the n. Depends on the n, right? If this is n is 7, there will be 7 terms. If this is 6, this will be 6 terms, right? But since we don't know the value of n now, that's why the last term will be Tn. So what will be the term before the last term? It will be Tn minus 1, right? Do you agree? Because it's before, right? Because it is consecutive, like 1, 2, 3, 4, 5, 6, 7. So this term, if this is the last term, the term before will be n minus 1, right? The previous term will be n minus Tn minus 1. And let's squeeze in the formula. Okay, this one I write belakang here. Let's write the formula for the Tn minus 1. So let's use this formula. Tn. The formula is AR power n minus 1, right? So this one will be, right? This thing will be AR power n minus 1, right? But for this case, your n is n minus 1. So it becomes n minus 1 minus 1. Understand? Because it's like the formula is AR power n minus 1. AR power n, but your n is n minus 1. Can you see it? That's why this becomes n minus 1 minus 1. Then it becomes n because negative 1 minus 1 is negative 2. Then it becomes like this, right? And it makes sense because this one is r power 1, r power 2, r power 3, it keeps going, and this will be n minus 2, this will be n minus 1. You see, the power always plus 1. Do you realize? This one is r power 1, r power 2, r power 3, keep on plus 1. And if you take n minus 2 plus 1, you will get n minus 1. Yes. Okay? So everything makes sense. Everything I write here makes sense. Right? So I'm just going to erase this. Okay, now, what happens if I take this thing times r? Because do you remember just now, I take everything here, I multiply with r, right? So that's why this a become ar, this r power 1 become r power 2 become power 3, power n minus 1 become power n. So can you tell me the ar power n minus 2, the terms that I just add just now, what happens when you times r? So let's write this at the back here. Okay, so what happens when I take this thing? I times with r, right? I times with r. So it becomes ar power n minus 1. Yeah, it becomes n minus 1 because ar power n minus 2, when you times with r, nothing, the a just write it, nothing happened. Right? R and r, they are same base, so we can times, but when you times the power, you need to plus. Okay, and nothing here is power 1, so it becomes n minus 2 plus 1. And negative 2 plus 1, if you press calculator, you will get negative 1 here, right? That's why it becomes ar power n minus 1, which is exactly what I write here, ar power n minus 1, right? So this is how, this is why I write ar power n minus 1 here, right? Because of this, okay? So I hope you understand. Now I'm going to erase this. So now we have, I will call this equation 1, I will call this equation 2, okay? And now what I will do is, I will take equation 1 minus equation 2. Okay? If you look at this Sn formula, down here is 1 minus r, right? If down here is 1 minus r, I will take 1 minus 2. Okay? I will take this minus this. But if the bar here is r minus 1, then I will take 2 minus 1. Okay? But it's the same thing now. Okay? I'll just show you this one first. Okay? I will show you how to derive this one first. So I will take 1 minus 2. So it becomes what? I'm taking the Sn, which is the 1, minus the next one, which is Rsn, right? Equals, right? So imagine I'm taking this baris, I minus with this baris. What's going to happen? You can see that if I take this one, minus this one, I can form a it becomes Sn minus Rsn, right? But what happens to all these terms? When you take this one, minus this, you can cancel them. If you realize there are some terms that looks the same, do you realize? So you can actually cancel them, right? Because you are taking this one minus this one. So you can see AR, when you minus with AR, it becomes 0, right? Because when you take this one minus this one, obviously the terms that are the same, they can cancel each other, right? So this one and this one can, when you minus, they will hilang, right? And then AR power 2, when you minus this, can cut also. And then what else will hilang? This one and this one also, right? Because they are the same. It means when I take this one, equation 1 minus equation 2, this thing becomes 0 when you cut them, right? Then what about this AR power n minus 2? Okay, let me tell you, this AR power n minus 2 can also cut with this term here, alright? This term can also cut with this, okay? Even though you don't see it, but you know that this term, the term before here, it will be AR power n minus 2. Let me tell you why. Because can you see, this A becomes AR. Can you see AR and AR here can cut? This one and this one can cut. And then this one and this one can cut. So obviously the AR power 3 can also cut with the next one. Because you can see the pattern. AR power 1, AR power 2. This one, even though you never write it, but you know it's AR power 3. Right? So it means that this term can cut. Like this cut. This one also can cut. That is why this term can cut with this term, the term before here also. Right? And then AR power n minus 1 and AR power n minus 1 is cut. So if you take equation 1 minus equation 2, the only thing left is this and this, right? Which is A minus AR power n. Okay? Minus that. Because minus, right? I'm taking equation 1 minus 2, right? This one minus this one. So what's left here is this one minus this one. All these things, when you minus, they will become 0 already. Because they cancel out already. Okay? You cancel out all these terms in between. All the terms in between, all hilang already. Because when you minus, you can cut them. Okay, okay, after you reach here, now you can actually form the formula for Sn already. Because you can see the Sn and the Sn here you can factorize, right? You can factorize here. The other side also you can factorize A, right? So you factorize both sides. Here you factorize out the Sn, okay? And then here also you factorize, but here and here you can only factorize the A, right? So what happens when I factorize the Sn here? What's happened? Okay, Sn divided by Sn will be 1. Okay, will be 1. Negative Rsn, when I take out the Sn, when I divide Sn, I left with minus R. Okay? Here, I factorize A. So A divide A is 1. Negative AR power n, I take out the A, I divide A, left with 1 minus R power n. Right? And now, you can find your Sn. It will be this one, which is A1 minus R power n, over this thing, 1 minus R. And as you can see, this thing looks the same, right? You see, this one and this one is already the same thing. So, you can write derive. It means this is how we derive the Sn formula. Okay? Okay, what if in the exam, what if they ask for this? They don't want this, right? They ask for this. They ask you to derive this. Then it's not the same already, right? Because this one is 1 minus R. But if they ask for this, it will be R minus 1, right? So what you do? Well, it's very easy. Instead of taking 1 minus 2, you take 2 minus 1. Okay? You take 2 minus 1. And what's going to happen if you take 2 minus 1? This thing will flip, this thing will flip. Okay? This thing will flip, this thing will flip. So it becomes what? It becomes Rsn minus Sn. Do you agree? Because you are taking this one minus this one. So this one will flip. This one also will flip. So it will become AR power n minus A. Okay? Because you are taking this one minus this one, right? And then the rest is the same here, right? First thing is you, you factorize up. You factorize both sides. So on this side you can factorize out the Sn. What happens when you take out the Sn here? It will become R minus 1, right? Because when you divide Sn, left with R. When you divide Sn, left with 1 here. What about here? You can factorize out the A, right? So when you take out the A, divide A, left with R power n. Negative A divide A is negative 1, right? And the Sn will be A R power n minus 1 over R minus 1. And this formula is this one, right? So you can write derive here. Okay? It means if the soalan asks you to derive the Sn formula, doesn't matter which one they ask, the working will be the same, right? The first 3 steps is the same. Okay? The only thing different is if they want you to derive this one, the 1 minus R version, you take 1 minus 2. But if they want the R minus 1, you take 2 minus 1. Okay? Yang atas sama. Okay? The first few steps is the same. Okay? This one depends on which formula they want you to derive. If they want this one or they want this one. Right? So I hope you understand how to derive the Sn formula. Now we are going to the last formula, which is the S infinity formula. Okay? So I'm going to erase because I need some space. So I think I can erase this. Okay. So I will try to derive the S infinity formula here. Okay. So the S infinity formula looks like this. A over 1 minus R. Okay. But actually, you have to write something beside. You have to write something beside. You have to write this. Modulus R lesser than 1. Okay. Okay, let me explain what is this. Okay, this symbol you know is modulus, right? But what does it mean by modulus R smaller than 1? What it means is the R has to be in between negative 1 and 1. This is what it means. Okay, so I repeat, modulus R smaller than 1, it means that the R has to be in between negative 1 and 1. Okay, but what if I say modulus R bigger than 1 like this? Okay, if like this, what it means? It means R smaller than negative 1, R bigger than 1. Okay, can you see the difference here? If smaller, in between. Satu positive, satu negative, in between. Right? But if bigger, satu positive, satu negative, but the negative one has to be smaller, the positive one has to be bigger. Okay, it's very similar with the quadratic. Yeah, when you find the quadratic inequality, do you remember? When you do quadratic inequality also it's like that one. If it's smaller, you shade here, right? If it's bigger, you shade here, right? And if it's smaller, the answer will look like this. Like x, like this. Okay, if it's smaller. If it's bigger, we have to write like this, this, and then comma x bigger like this, right? X smaller this number, and then x bigger this number, right? So yeah, it's like very similar, okay? So that's why you have to remember this. So remember this, modulus r smaller than 1, and then it means r has to be in between -1 and 1. Don't worry, I will explain later why have to write this beside, okay? Okay, for now I will show you how to derive the S infinity formula first. So S infinity, okay, what is Sn? Sum of first n terms. Then what is S infinity? It means the n here becomes infinity. What does it mean? It means you are not finding sum of first n terms, you are finding sum of infinity terms. Sum of first infinity terms. And infinity means it will never end. It will keep going. There is no last term. It keeps going. Infinity means it keeps going forever. That's what it means by infinity. So there is two ways to derive this formula. Okay, two methods that I know. I will show you both methods. First method is you will do the same thing here, right? So it will be T1 plus T2 plus T3 plus dot. But this time there is no last term. There is no last term because it just keeps on going forever. Because it's infinity here. If Sn, okay, let's say the n is 7. It means there will be 7 terms, right? But if S8, there will be 8 terms. But if it's S infinity, it means there is infinity terms. It means this thing keeps going forever, right? And then I repeat the same process. The next one, S infinity, and I write the same thing. T1, I write A. T2, I write AR power 1. T3, I write AR power 2. And it keeps going. Okay, it keeps going forever. There's no last term because it's infinity. Your n is infinity now. So it just keeps going forever. And what is the next step I did just now? I times with R, right? Yeah, you do the same. You do the same thing. You also times with R, but you will get R times S infinity now. It means the step is similar. Okay, the only difference is this one no last term. This one got last term, right? Because infinity means there's no last term. So when you times R, what happens here? Just copy from here. AR plus AR power 2, okay, plus AR power 3. Okay, what you're doing is basically taking all this times R times R times R, huh? And this one we don't write because there's no last term. It's infinity, huh? So I just keep going, right? And do you remember just now what I do just now? I take 1 minus 2 ataupun 2 minus 1, right? Depending on whether you want yang bawah, depending on what you want down here, right? So can you look at this formula? What's down here? 1 minus R. So can you tell me, should I take equation 1? Okay, this one is equation 1. This one is equation 2. Huh? So okay, I don't have enough space. So let me write. So this one is equation 2. So can you take a guess? Should I take 1 minus 2 or 2 minus 1? Let me help you. This one bawah is 1 minus R. So 1 minus R. Should I take 1 minus 2 or 2 minus 1? Which one do you think? Mestilah you take 1 minus 2 because if you want down here to be 1 minus R, you should do like this, which is you take equation 1 minus equation 2. And the reason is very simple because the formula here, bawah here is 1 minus R. If you take 2 minus 1, you will end up getting this. But it's fine also. You can also derive this if you want to take 2 minus 1, but you have to do some extra working. Okay? But the best way is to take 1 minus 2. It means you will take S infinity minus the RS infinity. Okay? It means yang atas tolak dengan yang ini, right? This one minus this one, right? So this one minus this one, you get this one, S infinity minus RS infinity. And what happens to all these terms here? Well, they will cancel, right? Which terms can cancel? AR minus AR, correct? Because you are taking 1 minus 2, right? So this one minus this one becomes 0. AR power 2, AR power 2, right? And guess what? The next term here, you can guess it, is AR power 3, right? Even though you never write it, but you can guess it, right? And guess what? What's the next one? AR power 4, and there will be AR power 4 here also. And it just keeps on cancelling each other, right? And I want you to know that all the terms from here onwards until infinity, all the terms can cancel with all the terms here, right? Because it's infinity, right? It keeps on going forever. But what I can tell you for sure is all the terms here can cancel with each other. That doesn't matter it goes until 100 or 1000 or infinity. All the terms that appears here, it will appear here also. that's why when you minus everything from here onwards, they will cancel each other. But there is one thing that you never cancel, which is the A. Do you realize this is the only thing that you never cancel? From here onwards, everything can minus with everything here, right? Everything here can cancel. So the only thing left here is just A only. It's just A only, right? And now you can factorize the S infinity. And when you factorize S infinity divided S infinity is 1. Negative R, okay, so negative lah. And then R you have to take out, S infinity you divide. So you left with R here equals to A. So your S infinity here is A over 1 minus R. And as you can see, this is the S infinity formula, and this is where we write derived. Okay? Or you can also write proven. It's the same meaning. Okay? Derived or proven. Okay? So yeah, this is the first method to prove this formula. Okay? Just remember you have to take equation 1 minus equation 2. Okay, let me tell you, if you take 2 minus 1, you will get this also. Yes, if you take this one, just now I take 1 minus 2, right? But if you take 2 minus 1, you can also get this. But you have to do some extra working. Because if you take 2 minus 1, you will end up with something like this. You will end up with Rs infinity minus S infinity equals to negative A. You get something like this if you take this one minus this one. Right? Rs minus A, and then you become negative A. But you will get the same answer. Yeah, because you will look like this, and then you will look like this. Right? And the negative, you can choose to write it down. It means it becomes A over negative R minus 1. Right? And then when you expand, negative R becomes negative R, and then the minus 1 becomes plus 1. Right? But the 1 you can write it in front. Right? So it's the same. Okay? I'm not going to go into details here, but it's the same lah. Okay? Just it's the same thing. Okay? But it's better if you do it like this. Because if you do it like this, it's faster, right? If you do it like this, you have to do some extra working, okay? But you'll get the same formula, right? Okay, I'm just going to erase this. Now I'm going to explain to you the second way to derive this formula. Yeah, the second way. So I will erase this. Okay, I'll erase all of this. So alternative way. Okay, so I'm just going to write here. Alternative. Okay. So alternative, right? This one also I erase. So this is the first way to derive the S infinity formula. Okay. But I want to show you the other way to derive the S infinity formula. So we can also prove the S infinity formula, derive this formula using the Sn formula. Yes, you can do that. But not this one. Not that one. You will use this one. Okay? You will use this one, this formula, to derive the S infinity. So let's write down this formula. Sn equals to A bracket 1 minus R power n over 1 minus R. Okay, let me tell you why we have to use this. We can use this. Why we can use this to derive the S infinity instead of using this? Because the S infinity formula down here is 1 minus R. Can you see this one is 1 minus R also? So it's better to use this Sn formula, right? Not this one, because okay, actually use this also can, but you have to do a lot of extra working. You have to do a lot of extra steps. That's why I don't prefer using this. So it's better to use this, right? So after I write this down, now you have to understand one concept, which is, because we are not trying to derive the Sn, we are trying to derive the S infinity. So we have to imagine what happens when the n becomes infinity, right? So if this n becomes infinity, it means that this n becomes infinity also, right? But you have to understand one thing first. If your R, okay, if your R, modulus R is lesser than 1, okay, if your modulus R lesser than 1, what happens? When n approaches infinity, R power n approaches 0. Okay, I know most students, when they look at this, they don't understand, right? They don't understand what I'm writing here, right? So I'm gonna explain to you. I will explain to you. Okay, you need your calculator. So let me get my calculator. Okay, so let me explain to you what this means. It means when your modulus R is smaller than 1, alright? I already explained just now. Modulus R smaller than 1 means your R is in between -1 and 1, right? So what does it mean by r in between negative 1 and 1? What does it mean? It means your r value is 0 point something. Yeah, it means your r value is 0 point something. So let's think of any number that is within this range, right? So let's say 0.7, right? Yeah, this number is perfect, right? So any number that is in between negative 1 and 1 is number 0 point something, right? So 0.7, 0.6, 0. Macam tu lah. So 0.7, right? And I want you to try to press calculator 0.7 power 10, 0.7 power 100, 0.7 power 1000. Okay, so I will first press this one, 0.7 power 10. So my calculator gives me 0.02825 and then it keeps going. Okay, it keeps going. Okay, yeah, but we just write four significant figures, but there's still a lot of numbers here. And then let's try to press this one, 0.7 power 100. So my calculator gives me 3.23 times 10, okay, but there are still many numbers here, times 10 power negative 16. Okay, do you know what it means by times 10 power negative 16? It means that I have to move the decimal point to the front. Okay, I have to move it here 16 times. Because negative means move this direction. If positive, move that direction. So negative, I have to move here, but I have to move 16 times. So it will be 1, 2, 3, 4, 16 times. So what do you think is your answer? Your answer will be 0.0000000, 15 zeros, and then 3, 2, 3, and so on. Right? So it means that your answer is very small. It's very near to 0. Right? Now let's press this 0.7 power 1000. Let's press 0.7 power 1000. Okay, my calculator give me 0. Yeah, my calculator give me 0. Okay. So what I'm trying to prove here, what I'm trying to explain here, when your base is 0 point something, okay, it doesn't have to be 0.7, it can be 0.6, 0.3, 0.2, whatever number that you can think of that is in between 1 and negative 1, any number here within this range, when you power a very big number, you will get 0. That's what I'm trying to prove here, right? That's why when you press power 10, you get 0.02825. When you increase the power here, the answer gets smaller. And when you increase become 1000, it becomes 0. It means when the power increase, the answer gets approaching to 0. Okay, I repeat, when the n increases, okay, when the n increase, the power here increase, the answer will approach 0 because the answer is keep getting smaller and smaller, right? So you understand the meaning, But all this will only happen if your base is 0 point something. Yeah, that is why here I write only if your r is modulus r lesser than 1. Modulus r lesser than 1 means it means your r is in between negative 1 and 1. This one and this one is the same meaning. It's the same thing. It's the same, right? This one is the same. Okay? So if your r is in between negative 1 and 1, which means your r is like 0 point something, and you make the n very big number, like infinity, then for sure your r power n will be 0. So now you understand what I write here? If your r is in between negative 1 and 1, which is 0 point something, and then when your n approach infinity, means your n gets bigger and bigger, the r power n will surely be 0 because your r is already 0 point something, right? Because I already write here, and then your n is like a very big number. Infinity means like very big, right? So that's why it's approaching 0. So when n approaches infinity, r power n approaches 0, right? So now what we can do is we can use this formula to derive the s infinity formula, right? So when we derive this, it becomes a bracket 1 minus r power n. So it becomes 1 minus, but the r power n I'll write 0. Why? It's because when the n becomes infinity here, the n here will become infinity, and the r power infinity will be 0. Okay, the r power n will be, it will approach 0. Okay, but only if your r is 0 point something. Only if your r is value is 0 point something. When it's like in between negative 1 and 1, then only this thing will happen, right? So over power 1 will be still 1 minus r. So now you get A, okay, 1 minus 0 is 1. So it means here times 1. But when you times 1, nothing will happen. So you will just leave with A over 1 times R. And this is the S infinity. And you can see this is same with this, right? So derive. This is how we derive the S infinity formula. Okay? But remember to write this, your R has to be, modulus R has to be smaller than 1. Means all these things can only happen only if your R is 0 point something. Okay? Only if your R is in between negative 1 and 1. Okay? Then only this thing will happen. Because if your R, let's say, is bigger than 1, like let's say your R is 2, then this thing won't happen already. Because if your R is 2, when you increase the power, it will not approach 0. Because your R is like 2, right? It's not within this range. Your answer will only approach 0 when your R is 0 point something. When your R is in between negative 1 and 1, and you increase the power, then only it's approach 0. Okay? So I hope my explanation is clear enough for you to understand. So this is 2 ways to prove the S infinity formula. Okay? So I'm going to erase this. Alright? So I hope you understand. So this is method number 1 to derive. This is method number 2 to derive. Okay? And remember, the condition for S infinity is always